Hello folks. Okay, I want to introduce a completely different approach to software design this time around. So nearly everything that we've looked at so far has been kind of what's described as a monolithic design, where we develop a program that is a thing unto itself. So, we go through and it might have a whole bunch of C++ files or whatever it might be, but it's a single program that runs and does whatever it is we need. It's an email program, or it's a browser, or it's a game, or it's a whatever, but it's this one thing unto itself. And all of the code for it gets, compiled or whatever together into this one single beast. And so we design it, we develop it, and we compile it to create this one single executable, if you like. If we need to modify it, we modify whatever part needs fixing and then recompile it and re-release it. So an alternative to this approach is the idea of a service-based design, where we have a whole bunch of completely independent components that run on their own. So each of these things is running separately, but they can interact with one another or be combined with one another to perform some more complex task. So if you want to actually perform a more complex task, you figure out which of these individual services to string together in what sequence, connect them together, let it run, and do your task, and you're done. So each of these services is sort of a component that's constantly being reused. Now what's nice about that is if you need to upgrade one, or you've got an idea to improve on one, the other components are still there and functional and running. The other services are still there and running while you quickly replace this one. You design a replacement for this one, swap it, and your new one takes over the role of the old one. And so you've got a whole slew of much more independent pieces out there working together. So it's a very different approach, and it can give you a more robust approach in the sense that these things are independent. We don't have to. They're if you like, your different services are more modular than what you had previously. You can replace individual pieces as it runs while the other pieces are still running. So it is a very different approach to things. I also wanted to introduce the idea of microservices, where it's taking this idea but breaking it down at an even finer grain, where we create really, really small tasks, really, really small services that are running independently. Maybe we take a cloud-driven approach where we've got hundreds or thousands of each of these services running at the same time. So if I've got service X, there might be 1,000 service X's running at one time. And when you need to string together a bunch of these things, you just say, okay, I need a service X right now. You go out and grab one of the ones that's available. And if some of the ones that are out there crash or go offline or whatever, or are being replaced or whatever it happens to be, the other ones are still there, so I can grab one of them. Right? So when a task is running, it looks for an available instance of the next microservice it needs. Now, of course, with services and with microservices, it does mean that we've got these communication and synchronization issues to address right now. We've got to be able to find the service that we need, and we've got to be able to communicate with it in an effective fashion, and we have to be able to deal with cases like, well, what happens if the one that I'm specifically communicating with crashes in the middle of it? Right? So we have a lot more coordination and communication issues, sequencing and scheduling issues to deal with. So there are some definite advantages, but there is some definite complexity that's introduced by trying to follow this kind of an approach. So it's resistant to failures in individual pieces of a network or individual devices. Right? If a handful of your service X's are offline, well, there's a bunch of others out there that are available. So it does make for a more robust system once you can get it up and working. All right, so again, the idea is that each one of these things should be able to run independently of other microservices and other instances of that same service. There's got to be some way to identify what type of microservice you are and what type of microservice you're trying to communicate with, and there's got to be some kind of a protocol to follow, some kind of known protocol to follow to interact with that other microservice. So you have to be able to say, I need a service X, and once you find one, there has to be a way that you know how to communicate with it so that it can give you the appropriate responses, give you the appropriate service that you actually need. So it's kind of the same concept as a function profile in that way. There's got to be some protocol that you know for how to communicate with this thing, some way to call this thing, some sequence of steps to go through to interact with it. So I want to introduce that concept. Again, it's something for you to be thinking about. The style of programming that we've been doing so far is not by any means the only style of program development out there. So there are other things to think about, other things to be aware of, and other things to start looking into and start exploring as you look at what you're going to wind up doing over the however long your career goes in this industry. All right, I will leave that one there.